Okay. Hello, everyone. Good evening. Good afternoon. I'm Rohit, and this is my friend Mao. Today, we'll be talking to you about power of Kubernetes CRDs to automate the underlay network of the edge. So let's get started. So as an agenda, I think first we are in one summit out here. So let's introduce Edge Cloud again, okay? And then talk about a bit of Kubernetes. Then we'll walk over how we can kind of design a network controller for the edge, and probably we'll touch upon a product called as Edge Network Controller using these concepts. And then we would want to kind of go over a couple of use cases where we have seen the applicability of this, okay, so that we kind of tie this in. So let's get started. So as we all notice, there are cloud sites popping up everywhere. You have regional clouds. Now it's getting disaggregated. You're getting edge clouds. Now you're getting far edge clouds. There are many ways how you could kind of represent that. So one of the main triggers for that from a telco side is the RAN disaggregation, the CRAN part of it. Then you also have the 5G core architecture, which is leading into such a network disaggregation. Then also a few enterprise cases also are coming up, as we saw in the keynotes today. So the beauty of this is all these cloud locations need to be interconnected using an IP network. And we need to see how we could automate that IP network connectivity. Okay, and we are taking a specific example of edge, and this can be kind of expanded, right? So first of all, what is an edge cloud? Again, we are in one summit, so we see that there are multiple locations which are coming towards the far edge. Think of it as a rack of 2 or 3 servers, right? One, probably a switch, okay? If you have redundancy, 2 switches, right? A very small location per se. And these locations could be on a building top, it could be near a stadium, it could be multiple such setups in a stadium, it could be in an enterprise premise, and so on. There are many ways how we kind of call this far edge, mobile edge, local edge, right? But however, there are a few common characteristics of these new edge clouds, right? The workloads, the edge cloud is tuned to kind of run a workload for a specific application. There are specific performance and scale requirements out there. You would have an SLA associated with that. Possibly the resource constraint is a very big criteria out there. You don't have a lot of, say, CPU, memory, resources available out there. So how do you actually plug in the networking out here? And how do you actually tailor it to the scalability of that application or workload? So that's what we are trying to kind of see through. To kind of quantify to that, Kubernetes, if you see, Kubernetes is being adopted quite widely for these edge locations, more widely than other approaches. And one of LF Networking's survey, which was, say, a couple of years ago, I guess, a thing which was pointed out is one of the biggest challenges for telcos to adopt Kubernetes is the networking part. It's not just the CNI. How do you stitch the CNI across into the network? So what we thought is first look into how Kubernetes control plane is, right? Kubernetes, it's a very widely used system, and a beautiful part of the system is it's extendable. So the resource model in Kubernetes itself is extendable, right? So how do you do it? You use something called as an operator pattern. Now, if you look at an operator pattern, what is underneath it? You have a schema definition for the custom resource. So that's the CRD or custom resource definition. Then you have a custom controller, which brings in the domain knowledge for that specific custom resource. How do you handle it? How do you modify it? How do you make changes? and so on. So using the schema, the API server in Kubernetes actually exposes the API to kind of manipulate that custom resource, right? So what we thought is, why not use this extensibility concept, especially for the edge, and why not build a very lightweight controller around it, right? And the domain knowledge in that case is, how do you configure the network? How do you apply the networking policies? How do you apply traffic policies, and so on? So we did that, and we are calling that the edge network controller. So we introduce a set of operators, basically with the domain knowledge. We started off with looking inside our house for Nokia switches, right, and routers, but this is vendor agnostic. So if you look at what Edge Network Controller, or ENC, does, it does the complete lifecycle management of your IP network at the edge, ties it into the wide area network or to a data center if and when required. Since we are leveraging Kubernetes and the operator pattern, it's tying into the whole ecosystem of tooling which is available around Kubernetes to kind of provide this networking as data or as code and deliver it in a NetOps fashion, right? And also by doing this, you kind of achieved a way to kind of define a very declarative intent of what your networking should be and pass it on to your edge network controller to configure the IP network for your edge locations. Now, the other advantage is it makes networking as a first-class citizen, right? Kubernetes is very good in manipulating compute and storage resources. Now networking is also consumable directly through the Kubernetes API. So the main characteristics of the Edge Network Controller is that it's programmable. It's leveraging Kubernetes. So the complete automatic resource conciliation loop is there. It's declarative, so it's autonomous. So in case we can tie into a more central system, we can pass data and metrics also along to a central system. But in case we lose connectivity, it doesn't prevent this site to not operate autonomously, right? It's lightweight. We saw that this for the edge location, it used only one vCPU, which is pretty awesome if you have dealt with network management systems. And it's vendor agnostic because we are relying on the model what is provided in the YANG, and we are converting that into the CRD and getting the custom controller programmed around it. Now, using this, we are going and investigating and actually deploying a few of the use cases. Certain set of use cases is targeted access. So you have your nodal configuration. Probably you may want to restrict certain sections of the configuration which should be manipulated in the network. So that's possible with RBAC. Then for the MEC site, the automation of the underlay and the application configuration, that could be done. Similarly, extending onto that for 5G slicing, that's again network configuration of the underlay and also the 5G function. And similarly, for the enterprise home network, you could actually deploy the security gateway workload and configure the underlay. Now, these are a set of use cases what we have come across while talking to our set of customers. I would ask Mao to go over a couple of them in more detail. Over to you.
You have the slide. Thank you. Well, I'm going to talk about two use cases. We've been working in defining use cases using Container Lab. I don't know if everybody is familiar with that, but it's an open source that you can use and start deploying any sort of setup for your network using containers, okay, Docker mostly. And then we did the same here with we add Kind Kubernetes. I don't know if you are familiar also with this, but it's a Kubernetes that you can run on containers. And we were using virtual wires to interconnect everything. Then we've been doing a lot of things with Container Lab. Right now we are working with segment routing to start also doing orchestration and that, but we couldn't make it on time. Then we're going to show all these two use cases right now. Then the first use case that we have is BGP mode Kubernetes load balancer. For who is familiar with the load balancer, it's the most popular service in Kubernetes. Then if you go to the public cloud, it's actually it's built in the APIs. Then you just need to start your Kubernetes instances, start deploying your replicas of your application, and then through the APIs you can start exposing directly for Kubernetes any of the applications. But when you try to do that on premise, it's a different story because usually all the operation for the load balancer is very manual. You need to go to the appliance, try to go for the IPs and ports that you have in the Kubernetes nodes and say, okay, let's start, balancing everything over there. But as soon as you start adding more replicas or moving applications, you need to go again, and sometimes you need to open a ticket because it's not the same team. Well, everything gets very, very messy. Then what we did here is we expose all the edge fabric. We are talking about, we started using 4 leaf switches, 2 spines, and a border leaf. And we connected the many, like I think 4 workers and a controller to the leaf. And then we're starting to create the intent. The intent, the idea is, well, first, we are working with MetalB. MetalB supports layer 2 and layer 3. If you are familiar with that, you know that layer 2 doesn't work for most of the use cases that you need, unless you want to have problems later, is you're switching over to different other replicas. But in the case of BGP, it's a very good solution. But the Kubernetes team need to understand fabric. They need to go and start creating BGP peering, start creating policies. If you want to use NCMP, then you need to be a little more detailed on the policies. We did it even a little more complex because we define everything over EVPN. Then we use eBGP for the underlay to make all the loopback interfaces between the different switches be known on the fabric. And after that, we created the EVPN on top of that layer 3. And we're starting to do the peering from the worker nodes on the Kubernetes to the leaf. The idea of that is, I'm using ECMP to balance, the traffic. And then the big problem that you can have if you're trying to do this manually, the Kubernetes team works independently from the network team. Then when you try to do anything with BGP on the fabric, probably you need to start creating a ticket, have many meetings, try to explain why would you want to do that. And every time that you're going to add a new prefix to the load balancer, probably you need to do the same. Then what we did is, because now we are working with ENC, we put everything in CRDs. All the jam model of the fabric is actually provided by in CRDs in the Kubernetes. And we are using a controller to do the reconcile of the state of those CRDs directly on the fabric. Then what we did is, with GitHub, we created 2 different files. Well, if you are familiar with Helm, you have the templates. We created sort of a blueprint on the templates with all the information that we needed to set up on the fabric. And we have the values that is actually having the information of the prefixes that we are going to use, for example, in the load balancer. And because of that, also you can set the policy through the CRD, the BGP policy through the CRD with the same prefixes. Then we put everything together in the same file. Then not just the fabric, also the configuration of the load balancer, everything together. And then we put that in a GitLab repo. We use Argo CD to start taking all that information. Any change that we were doing here was actually taken directly to Kubernetes through Argo CD. And in a few seconds, we have our load balancer ready for all our Kubernetes guys to start exposing their applications. It was really easy. Then we We did day 1 and day 2. Day 1, for example, because if you're familiar with Container Lab, you need to go and set up everything over again and over and over again every time that you are doing changes. Then we created finally also intents for the underlay using eBGP, another intent for the VPN, the layer 3, and also we created the final intent for the metal B to start doing the day 2 when we wanted to do changes on the load balancer and so on. Then this is the whole file for the configuration. Actually is very simple. We can just go and add prefixes at the top of that on the do the commit, from in the repo. And Argo CD is going to take all the information directly to Kubernetes, and now we have our new prefix in the load balancer service. Everything working on premise. Okay. We can share also this information with you. If you are working with Container Lab, we can share all the templates and all the information that you need to start working with it. We were working with SRL, then you don't need a license for the switches, but Container Lab also supports Cisco, Arista, any other switch or router that you want to try. Any question from the load balancer? Yeah. Yes.
So it is Helm. So it is really an extension on top of Helm, basically.
Yes. Well, yes, it's Jam. What we were using in the templates, we were putting the CRDs, all the logic, with the Jam model that actually it's based on CRDs directly on the templates. And the value file is only having the specific values that I need to change every time that I need to do an operation.
Okay. Exposing the value that needs to be changed.
Yeah, to make it simple, because we don't know if this is going to come from the network operation or it's going to come from the Kubernetes team.
Okay.
Okay. Then you can have a merge in the GitHub repo to control who is going to do the changes. For example, have someone up to approve the merge or any change.
Okay.
Yes. There's one other.
Thank you. What protocol are you using between the CN and the actual hardware and the switches?
It's GNMI. Okay, but any model-driven protocol which supports model-driven interfaces can be utilized.
So the CRD is based on the Young model, and then the ECN converts that into GNMI to control the switches. Thank you.
There is another question back there.
Okay, I had the same question, but I have one more question. Does the CRD controller, does it automate Metal LP configuration also? Today, Metal LP uses config map.
Well, we don't need to do it because actually the load balancer already is available, fully available using the Kubernetes APIs. You can set just the config map with all this setup that you need in the Kubernetes, and you don't need to even touch anything, like some sort of CRD.
Okay. So this CRD controller or this CRD is mainly meant for automating layer 3 switches.
It's for the network infra. It's for the leaf, the spines, and portal leaf.
Yeah, so you got it right. Like application is a first-class citizen in Kubernetes. So we are just extending the networking part to be a first-class citizen. Okay.
Well, the other case that we got was a home enterprise network. We were working on this because of a customer requirement. Basically, he's using SD-WAN for security services, for VPN. But he wanted to also, because it's an MSO, he wanted to also start working with a security gateway, with an IPsec gateway directly on the edge, working as a workload on the Kubernetes. Okay. Well, this is just a comparison, but the idea is there are many employees working at home, and they wanted a secure connection to the data center or to the corporate offices. Then in those cases, you have MPLS most of the time. Then it's a little hard to SD-WAN to try to make the conversion from a VPN, like a IPsec, and then going directly to a MPLS. Okay. Usually the application doesn't have this sort of integration at a low level. Then what we did here is we were working with two applications. One was a strong swan, okay, client and server. Strong swan also can be set up directly through Kubernetes APIs. You don't need to do any complex thing. And also we have the security gateway from Nokia. In that case, we treated the security gateway as another network device through GNMI. Even that was a workload, we set up everything using also the template, the values and the template from Helm. Then, as you can see here, we got only, for this use case, we defined a leaf and a border leaf. But the border leaf was working as a router, to be honest, because we were exposing the MPLS services directly on that border leaf. Okay, was a router, not a switch. And the leaf was providing layer 2 domains, or VRF, MAC VRF we call it, where we connect the different customers. We got many companies and customers, and everybody was using different MPLS services. Then you need to be very careful what customer is going to be connected to what layer 2 domain, and because with that, that is going to go through that MPLS, to the corporate offices. Then the YAML file, the template have all the logic of the YAML, but the profile of the service was in the value files, again in GitHub. Then every customer have their own profile with the different services, the IPsec gateway settings, the VLANs, the layer 2 domains, and the MPLS services. Okay? And what was a little long, then I didn't want to put the example here, but we can share again the information if you want it. And basically what we are doing here is also working with a closed loop orchestration, automation. I mean, the problem that we got over here is, well, we created the intent to deploy everything, the profiles, but the other problem we're starting to run into was the workloads were moving around. And the VLANs needed to be also moved, with the workloads. Sometimes to a different connection to the switch, physical connection, or sometimes even to a different switch from a different worker. Then the solution, the CRD, we did for this controller, is also working with a secondary member of CNI plugin. For example, if you are using the Mac VLAN or SRIOD, we added a second member for the CNI. And we were using also LDDP from every worker to understand the topology of the fabric, what port was connected to what worker. And then with that, every time that the workloads that were moving around, or we were creating more workloads because of the services, then and everything through Kubernetes APIs, again, with the templates and the values, this controller identify what worker was connected to what switch and what port and what services, and created the VLANs in the right place. Then with that, you are avoiding to pre-provision thousands of VLANs to just be sure that when the workloads are moving around. Okay, this is something happened also. It was happening in 5G core when we were testing the 5G core, and then we call that service network scale. Then with that, we know that when the workload is moving around, we always have the VLANs in the right place. Okay, and we don't need to over-provision something that actually you can have the intelligence directly in Kubernetes. Okay, then any question about this use case? No? Any other question about the concept? Okay, thank you very much.
Thank you.